Very good. Okay, then let us move to the regular agenda. We have two items on the agenda for the Rules Committee meeting. I'm going to reverse these because we do have someone present to speak on the first item, and we want to give him the opportunity to do that. So we will take, first of all, the water complaint desktop analysis.
Okay. Mr. Mayor, this item comes out of the Public Works Departments, and it's an item where there's no board action per se on it. It's something to give some additional education to the citizenry and to the board. Over the past several years, we've had a number of complaints that have come to us with issues of discolored water, chemical buildup with some of the water infrastructures in people's homes, and various complaints. While the village's drinking water supply has been recognized as the best tasting water in the state of Illinois in 2010 and 2012, we're always looking for whatever insight we can give our residents to give them additional peace of mind on the quality of the drinking water supply. As the board is aware, and I'm sure will be referenced this evening, we typically send out, as mandated by the IEPA, a consumer confidence report that goes out each summer. Ours hit resident mailboxes over the last 30 to 45 days. So residents who are looking for information about that can find it on our website if they did not receive it. In addition to the report that's given this evening, Mr. Lawrence's report is also going to be available on the village's website under the Public Works icon under Water System Improvements. With that introduction, I would defer to Director of Public Works Ken Iyer or our Chief Water Plant Operator Ron Erickson if there's anything else that you would share by way of introduction before we get on to the presentation.
You covered it pretty well, Manager, but I'd like to add that Mr. Lawrence has over 30 years of experience in the water industry, and he specializes in chemical analysis and corrosion control of the water system. With that, I'd like him to do his presentation.
Mr. Lawrence, if you come to the podium.
I'd like to start by saying I feel a little bit humbled by the last two men who were up here, but I'll try to live up to what they have. As Ken said, I've been in the water industry for about 30 years. I'm a professional engineer. I specialize in treatment of potable water and in corrosion, two somewhat disparate ideas, but you'll see as we go on with the report that it just happens to fit very, very well with the issues that we're dealing with here. This is called a desktop analysis. Just so we're all on the same page, well, first, let's, as Mr. Mick mentioned, Park Forest has received and been judged to have the best tasting water in all of Illinois twice in the last 4 years. I'm sure there are people out here who might take some issue with that, but you should know that your water quality is the envy of an awful lot of your surrounding suburbs who don't have quite as good a water. But the administration noted that they'd had quite a few, or at least what they would consider quite a few complaints, and therefore they commissioned this study. Now, a desktop study is defined as an office study which compiles historical information and literature to assist in determining appropriate treatment. This became kind of very popular when the lead and copper rule came into effect some years back. It was a way of checking what your conditions were to determine what you might need to do. And what it does, it uses existing information. We don't go out and do a whole lot of testing and studying of things out there. We gather information that you already had and have been keeping. We compare that with various studies in chemistry and things that are in the literature that tell us how that might affect the water in your system. Take and compile and correlate all that data, and then draw conclusions from that, from previous studies and experiences, to determine what the probable causes for the issues you're looking at are. and then propose possible solutions. So that's what we've done here. This is a log of the complaints from June 2007 through December 2011. And I believe we had a total of about 287 total complaints over that period of time. Now, if we divide that up over the number of years, that's not really a lot of complaints. But there's two things we want to particularly notice. There's a clump of complaints right here in late 2007. Unfortunately, I can only point at one slide. And there's another group out here in late 2011 into 2000, or late 2010 into 2011. We could kind of blame these first set on the startup of the new plant and just the shakeout and getting it operating properly. That doesn't explain these over here. Now, most of these are red water. You can see the other types of complaints are fairly small in there. Let's look at the types of complaints that we had. As you can see, the vast majority are red water, almost 70%. Chlorine tastes were about 6.5%, and white water, white deposits were about 4.7%, a little less than 5%. There were about 19% that were complaints that related to low water pressure, billing, or some things that we couldn't quite quantify exactly what the complainant was asking about from what was logged. So there are some that we're not quite sure what they were, but they don't appear to have anything to do with water quality. So we really had 3 water quality issues: red water, chlorine taste, and white water. Now, we're going to go through here, and I'm going to touch just briefly on the red water and the chlorine tastes and spend a little more time on the white water, mostly to show how we come to the conclusions that we came to, and came to the ideas of what might be done. For those who are truly interested in all the details, as Mr. Mick said, the entire report is on the village website, and you can go through it in detail. So, let's look at a map of the complaints. And as you can see, the red water complaints are all over the village. However, one of the things to look at is there are clusters of complaints. Lots of different clusters. That suggests that there's something going on out in the distribution system that happened that caused that set of complaints to occur. One of the things we looked at, and they're not all here because only those ones that were actually logged along with the complaints are shown. We've got main breaks. We've got fires. There's a fire up here. There's some fire over here. And we've got some other stuff where we've had some construction activities going on. And each one of those seems to relate to a cluster of complaints. So it looks like things that disturb the water out in the system create the red water complaints. So that gives us a clue as to where this is coming from. You'll also notice these red areas here. These come from some recent work that was done in what's called unidirectional flushing by a company called M.E. Simpson, where they do work to clean out the mains. And these were areas where they found they could only get very low velocity flows in the mains. And we'll talk about what that might be in a second. So the clusters seem to relate to events. Looks like there's something that happens that triggers these things. Now, most of the Park Forest water system was constructed right around 1950. It was constructed of unlined cast iron pipe, which was pretty much the state of the art back then. Since that time, we've determined that that's probably not the best thing to use, that we line pipe now because of this. That's corrosion on the inside of the pipe. And what we'll probably find, this is not everywhere. However, anywhere you saw those red lines on the map, there is probably some pipe that looks something like that. A little better, a little worse, but something on that order. Now, before we even started this study, the village started 2 programs to address that. One is a main replacement program, actually going through and replacing sections of main in the system to eliminate that. Unfortunately, when you figure most of these are probably 8-inch main, something like that, 8-inch main runs somewhere around $200 a foot to install. You can see that that adds up pretty quickly. There's no way that the village can replace all of the main that needs replacing in a very short period of time. This is going to take a while. So they started a second program in the interim. This is the unidirectional flushing program. M.E. Simpson went through and basically flushed the entire water system, starting from the water plant, working out throughout the system, to flush any loose material out of the mains. That was partially successful. Because of those areas with the low flows, they couldn't flush everything. So what is going to happen from here out is the village will take, personnel will do targeted unidirectional flushing. Instead of trying to flush the whole system, there are particular areas where problems appear to continue to crop up that they will then flush in that same manner. Let's look at the chlorine complaints. Again, we see some clusters. Clusters down here, cluster here over in the ash section. However, what seems a little strange about that is those clusters where people have complained of the taste of chlorine in the water aren't near the water treatment plant or the chlorine booster station down by the golf course, the 2 places where chlorine is added. If it was strictly something coming from the plant, one would expect that your complaints would cluster around the plant or around the booster station. They don't. We also looked at what the residuals, the amount of chlorine that's in the water, in the dark little dots when it leaves the water treatment plant, the light ones as it's measured out in the distribution system. Those 2 lines represent the range of chlorine residuals that Chicago maintains in its water. As you can see, these are far lower than that. These residuals are at a level where virtually no one is going to be able to detect chlorine by taste. It would take very sensitive instruments to find this at those levels. It's a very low level of chlorine. So we don't see any evidence that supports those complaints. That doesn't mean it didn't happen. It means that there's no data that tells us what happened. So we can't really answer that one. Village's program for this is to attempt now, to the best of their ability, whenever a chlorine complaint comes in, to get someone to the location immediately or sooner if possible to get a sample and test, to see, gather data to find out, is there actually something there or is this something entirely different? So that we can take then and perhaps determine what's happening and fix it. Now, whitewater, or white deposits. They're actually 2 different things, and some of the complaints, it was hard to tell which the person really had. But you'll notice they're pretty even throughout the whole period of time. We've got a few right here, right after the plant. We got a little spike there, but they seem to run pretty much continuously throughout the period of the study. That suggests that startup of the plant isn't the issue. and we'll look at where they are. This is a little difficult to see, but we've got ones here, we've got ones in the middle here. Again, these are spread all over the system. They don't appear to be clustered, really. They're pretty much random. So this one doesn't look like this is something happening out in the system that's causing this. This has got to be something that's running continuously. That takes us kind of back to the plant. Let's look at what can cause white water or white deposits. White water, white deposits. White water most commonly would be some sort of a dissolved or entrained gas. It's similar to if you take a soda and you open the bottle, all of a sudden there's bubbles. It becomes kind of opaque. There we go. The other thing could be some suspended white solids of some sort. Very easy to determine the difference here. You take a glass of the material, you set it there for a few minutes. If it's gas, it'll start clearing from the bottom, clear right up. If it's suspended white solids, it will either start clearing from the top and settle, or it won't take and clear at all. It'll stay the same. So that makes it pretty easy to determine which it is. Dissolved or entrained gas, sometimes you get water out of wells that has gas in it. CO2, methane, things of that nature can be in well water. If you look in the report, we'll show a diagram of the plant that shows that couldn't be our effect here, because this water goes into a tank where it's exposed to the atmosphere, and any gas that would have been in there would come off before it got in the system. What could do this, though, is somebody out, a contractor, putting together the mains, filling it up too rapidly, not venting all the air out of there. That air gets pressurized into the water, dissolves, and when it comes out your tap, now the pressure's off, it comes out. None of that's harmful. It can be annoying. If that occurs, you should call the village, because they'll want to go to their contractor and tell them they did this wrong, do it right. White deposits, on the other hand, the most common thing one thinks of, particularly when you have water, such as the villages, which is softened, so we're starting with hard water, is hardness scaling. The hardness minerals coming out and causing a scale. But there can be other dissolved solids that, when the water evaporates, are left behind, leaving a deposit. Said the most obvious thing would be hardness. So that's the first thing we look at. This mess is a graph of the hardness in blue of the water coming out of the treatment plant, and in orange the alkalinity, which is another thing that affects hardness and whether it precipitates. We can see we had a little issue sometime after startup, and then we lost control of the plant for a while. But as we come along here, you can see that back under pretty good control. This blue box shows the hardness of Chicago water, which they do not soften. So this is the natural hardness of Lake Michigan, falls in that range pretty much all the time, what a lot of your neighbors have. You can see at the end here, control is pretty good, that we stay pretty much within that range. Yet we have complaints of deposits. So let's look again. Like I say, we still have these deposits even after it's gotten control of the softening process. Softening process doesn't appear to be the issue here. It's under control, and we still have complaints. Another thing that we use to measure about whether hardness will come out of the water is something called the Langler index. Basically, it's a measure of whether the water is supersaturated with hardness, has more hardness in it than it can keep, or whether it's deficient in hardness and wants to dissolve hardness minerals. This blue area in the middle here is sort of neutral area. We don't expect any deposition or dissolution. This area, which usually shows up more pink, is where we would have deposition, and this area down here we would expect to be dissolving any scale that was there. As you can see, we did have a little excursion here, but for the most part, we're right in that area where we would not expect to see any kind of scaling from hardness. That doesn't seem to be the case, that we have that as the thing to look for. Looking at this pipe again, if for any significant period of time we'd been depositing, one would expect to see white deposits on the inside of the pipe. That's the first place it's going. In fact, that's a lot of places take and intentionally do that to help line their pipes. They can cause it to deposit a bit, and it helps protect and prevent corrosion. We don't have that here, so that isn't the issue. So we looked at what the other solids might be in. This is a measure that was done over the month of November 2011. And we measured something called total dissolved solids. That's essentially a measurement of all the different minerals that are dissolved in the water. That's not something that the water plant would normally do because it doesn't have any control applications for them. It's not something that controls their treatment process at all. And this gray area shows those values that they got, checking several times a day all through the month. These were the measures. A big bright red line is the point where it is expected, if you're above that line, you will see issues with deposition of solids. That there'll be aesthetic effects that are undesirable when that exceeds that. And you can see that actually exceeds there about 72% of the time. So we've got too much solids in the water. This line down here is approximately where we would be if they softened the water to zero hardness. It's not a good idea. You wouldn't like the taste of the water. You'd probably increase the red water problems. And the American Heart Association would tell you that that's rather unhealthy to have water that's soft. But even then, we still occasionally go over. So, what are those materials? They're not hardness. They're something else that's in the water. Something coming out. So, we got a hold of some of the solid material, and we sent it to a lab to see what we had. And this is basically, anions are ions with negative charges, cations are ions of minerals with positive charges, and they measured most of the standard ones that one might find. And we get percentages for the different materials that are in that solid material. If we look here, these are the anions and cations that make up hardness. And they total about 12% of the material. So that's certainly not the issue. It's only 12% of what's there comes from hardness. Most of the stuff is in these two boxes. This is something called sodium sulfate. Sodium sulfate, its use is often in washing stuff, dry laundry detergent. That's not where this came from, but it's the same chemical. It's not anything terribly harmful, but this comes out of the well water. It's in there. We see a little more of it probably now because of the way the new treatment plant operates versus the old one. The old plant didn't completely soften in one process. It partially softened the water using the same process we do now. It then took some of the water and ran it through a really big version of your home water softener, where it took out all the hardness from that. And it probably took out a significant amount of the sulfate here at that same time. And then they put the water back together. So we probably had a bit less of this then. I can't tell you how much less. We don't have samples from then, so we can't really say what the difference was, but it appears that this probably increased a little bit. Okay, what can we do about all this? Well, the first thing, we could lower the hardness some from what the normal hardness that we go for now is. Now, these are the 6 wells and the water that comes out of it. And particularly notice these pink bars. That's the total hardness in the well water. And as you can see, it differs a lot between the different wells. One of the issues and one of the reasons you saw that spiky line on the chart is the way we've controlled the treatment plant so far is pretty much the common way most places do. They soften the water several times a day. They take a sample of the water, the finished water, measure the hardness. If it's not in line with what it's supposed to be, change the chemical dosage to adjust that, and then they see. There are some issues with that. If you have a system where the water coming out of the wells is all pretty much the same, that shouldn't be a problem. That works very, very well. When you have a situation like this, where the water is very different, every time a well comes on or turns off, the water coming into the treatment plant changes. The chemistry of the water changes. What we're proposing to do is to start using, I hate to use the word proactive, but since it's such a buzzword, but looking at each time a well comes on or off, grabbing a sample not of the finished water, but of the water coming into the plant, and then calculating the dosage of chemicals required to soften it and making that adjustment. Because if we wait for the finished water, we've got 4 to 6 hours of water in the plant that hasn't had the right dosage of chemical, because that's already passed through before it gets to be finished. So this way, we calculate it, we treat it, we adjust to that, and we should be able to make that spike come down to just a little ripple and be very close to a constant. When we do that, we can take and decide to change slightly, get a little more of that total solids removed. We're also looking at a process to try to remove more solids. A well plant, unlike a plant designed for a surface water like Lake Michigan or the Illinois River, that is not really designed to take out dissolved solids particularly, other than hardness, as your plant is designed. And this is a particularly tricky one because sodium sulfate is very soluble, so it's hard to get out. But we're looking at some possible changes in treatment that might be able to remove at least some of that. The question will become, can it be done without making significant changes to the existing plant, which would be expensive? Can it be done without significant changes to operating cost, which would be expensive, and without creating any other issues such as increasing red water problems, increasing any of your other issues that you might have? We've got good water, we don't want to do anything that would make it worse. Now, summarize what we found. First thing, park water, forest water is safe. None of these issues have any health implications whatsoever. Mentioned the annual water quality report. I picked that one up out in the lobby a couple weeks ago. So there are copies available in the lobby if you haven't found yours in the mail. It is also posted on the village website, so you can get that. This is the report to the customers, but it gives all the information about everything that was reported to the EPA about the water. And shows that there have been no violations, that everything meets water quality requirements. You can also go to the EPA website, and you can take and look at all of the results that have been reported, not just the summaries that are in the Consumer Confidence Report. So we've got three issues: red water, chlorine taste, and white deposits. And what can we do about them? First, red water is being addressed by water main replacement. When all of the unlined cast iron pipe is gone, so will the red water be. But that's not something that's going to happen overnight. It's going to take time. Second is the targeted unidirectional flushing. Now, some people noticed in the original flushing that actually they got more red water for a while. That's because of those areas with the low flows that couldn't be completely flushed. Things were moved a little further, but didn't get flushed all the way out. That's what the targeted flushing will do. Each time it'll move stuff a little further along and get more out until hopefully we can keep the red water to a very small minimum. And finally, obviously, if you see red water, don't wash clothes, don't do things that might be stained. But if it happens, if that happens, the village has a substance called Red Be Gone available at the village hall that they can provide to you, which should get it out. It doesn't always get all of it, but it does a pretty good job. Chlorine taste. We don't know what the issue is yet, but the process to determine that is to try to keep rapid responses. When there's a chlorine complaint, get someone there to test the water, find out what's going on, take care of it. And then we'll find out where it is and what we can do. For the white deposits, we're looking at better control of the softening process. Try to keep that down so that we don't get the spikes. Plant staff is going to be doing some testing to try to determine if they can remove more dissolved solids with the processes that are there now, either through some chemical addition, things of that nature, and to see what that might cost if it works. In the interim, what we'd recommend to residents is, if you have deposits, use an acid-containing cleaner, something with vinegar, lemon juice, something of that nature. Tomato juice, if you don't mind the red on things. That will help dissolve the materials and get them off. You can also look into, for things like showers and that, they have material that sprays on the shower automatically, which causes the water to sheet and run off, so it doesn't dry on the surface. Because these deposits only occur when water dries on a surface. So if we can get that water off, there isn't any issue. It doesn't cause any problem. And I'll take any questions.
Well, very good. I feel like I've heard Sherlock Holmes giving an explanation of how he caught the red-headed league. I mean, it's very involved, and I appreciate the background, the details. Questions from trustees or comments? Looking up and down the dais. Trustee Kopachinski?
Is it possible that there could be chlorine buildup out in the system?
No, not really. Chlorine doesn't do that. Okay. I mean, if it isn't in the water, it isn't there. I mean, there could be a spike that went through, but why folks between where the chlorine's applied and where there was a complaint didn't notice it doesn't, I mean, there were some cases where you could see if you have a really big transmission main and for some reason it goes flying through and happens to go out this particular part of the distribution system, something could happen. But again, the problem is we don't have any evidence to support that. So right now the process is to get evidence, see what it is. Maybe it's something people are tasting which has nothing to do with chlorine, but that's the way they're interpreting it. That could be something. So if we start taking samples and yes, people notice something like a chlorine odor and they test and it's not chlorine, then it's time to get some samples when that happens, get them to a full-blown lab where they can do a complete check of what's in there and tell us what's in there. And maybe there's something from somewhere that's getting into the system. That could be a problem. But again, we don't have any evidence right now to tell us that.
Any other questions or comments from anyone? Well, Chuck, I want to thank you for the report.
You're very welcome.
I think it's very thorough. It gives us a real benchmark for responding to questions from residents. I think it also underscores something that I've mentioned to residents when they've raised concerns with me, and that's the importance of them contacting the water department immediately. Because if you're going to test for chlorine, for example, you can't do it 6 days after someone supposedly noticed it. And I know a lot of times the complaints that are brought to my attention when I start to ask, well, when did you notice this? It was, well, 4 weeks ago or 6 weeks ago or whatever. And whether it's the red water or the white, deposits or the chlorine taste, the key thing is to get in touch with the water department right away. And, and for residents, I think the importance of this is that many times we don't know what necessarily could be causing a problem, but if you call us and tell us that you have that problem at your residence and we can come out and take a look, we might find that we can, it's going to also aid us in correcting problems in addition to making your water better tasting or more palatable based upon what doesn't look tasty isn't going to taste good just by virtue of what you think it's going to taste like. So, so I think all of this gives us some real good benchmarks, and we really appreciate the good work that you've done. Tom?
The only thing I would add, just to reiterate, I think Ron had shared this with us previously. For residents who are looking for more information or to see these details at length, go to the village website, villageofparkforest.com. Under the Public Works link, there is water system improvements. And then if for some reason you're looking for the State of Illinois IEPA website, it's www.epa.state.il.us for more details.
Very good. Thank you very much.